Okay, example 2, same deal. It says add, I see fractions, so once again my very first focus is the denominators. I got 5a squared times x and I've got 5a squared times x. Those are exactly the same. Common denominator exists, so we're ready to go. Now what we have to be cautious of here is this. How many terms are on the top? 2 here and also 2 here, right? This minus sign is minusing this entire fraction, not just a piece of it. So this minus sign is actually attacking the 3x and also the negative 2. Be careful, that happens quite often with a lot of problem types when fractions are involved. So you'll have more than one thing in the numerator. There's a minus sign in front of the fraction. That minus sign goes all the way through. So when I take a look at this problem, my 5a squared x is on the bottom. I'm just going to go ahead and write this. What I usually do with a problem like this is I do it in 2 steps. Step 1 is I write down what the tops will be. So this is just 5x plus 7, because there's no sign in front of that fraction influencing anything. So the signs are what they are. 5x is positive, 7 is positive, everything's fine about that. The second fraction, this minus sign is going through this whole thing. So minus 3x, and then minus 2 is equal to plus 2. And again, that happens quite often. When we get to a point where we're adding fractions on a test of this variety, I'm sure this type of problem will show up on at least one test where there's going to be a minus in front of a binomial numerator. That minus is going to distribute through. So again, I just write down what I should get just from getting that, just to make one big fraction out of the whole thing. And then I start focusing on like terms. 5x and 3x are like terms. Those can be created something new. And let's go with this color. This 7 and this 2 also are like terms, so we can add those together to make something new. So the overall result, 5a squared x on the bottom, nothing ever happens to the bottom. Once the common denominator exists, that's what it is the rest of the problem. If I add the 5x and the negative 3x, what do I get? The purple ones.
Oh, 2x.
There you go, 2x. Subtraction because the signs are different, and positive because 5 is bigger. And when you're adding letters, powers don't change. We have 5x's, we take 3x's away, we're left with 2x's. We look at the neon green ones here, 7 and 2 make what?
9.
What kind of 9?
Plus.
Plus 9, so we're going to put plus 9. And that's our answer. Okay. You are not finished until the numerator is as simple as it can possibly get, all like terms being combined, and you have the correct numerator over the common denominator that exists in the problem.
It's